On behalf of ABCZ, I would like to thank the invitation of Datagro, who has brought us here to be part of this panel. Together with all of these strong players here, we're going to learn a lot here. We have here today Dr. Luiz Josahkian, Superintendent of ABCZ. He's a zootechnist, Technical Superintendent of ABSC. He knows a lot about genetic modeling, and he's going to talk a little bit about his experience. Dr. Luiz Adriano, agronomist, also master's degree on phytotechny, right? And Cris Morais, she's president of the Livestock Chamber, as secretary of the agriculture of the state of São Paulo. All right, so each one is going to talk a little bit about their experience. Our subject here today is production efficiency in the extension of food production. This is a challenge that the producing segments of our country will face in the next few decades. The production is increasing more and more, and we need to be more and more efficient as well. And this efficiency means producing more with better quality and less impact to the environment. So this is the word of order, efficiency. The previous panel broached the subject of sanity, and these three subjects that we're going to discuss, sanity from the previous panel, genetics and nutrition, these are the three, this is the tripod that supports production of animal production in any segment. Sanity, genetics, and nutrition are very important. And we'll conclude with Chris's presentation of the case and how it happens in practice in a farm that is efficient. So I'd like to start with Dr. Luiz Antônio Josahkian to talk a little bit about genetics. What is the current status? What is the state of the art of genetics today in terms of livestock, and what we can expect for the next few years? What the science will bring us, what it will add to this constant and effective search for efficiency in our business. Luiz, the floor is yours. Thank you, João. Good afternoon. It's an honor to be here with all of you, with our colleagues here in this panel, and to bring a little bit about the contribution for such an important subject and such a relevant subject that is sustainable production. It's not only in the headlines of the newspapers and magazines, it's now reality, right? So I brought here some information. Okay, here we have the presentation. Like João mentioned, I'm going to discuss a little bit about genetics, more specifically bovine genetics, and I'd like to contextualize a little bit of this subject say that we're living a moment of transformation. This is clear for everyone. The speed of information, and there's possibly an excess of information that it's hard to filter and process all of this information. But the fact is that we know that in the future, if we don't have a strategy specifically related to the production system, it's very risky because systems react poorly to improvisations. And here in Brazil, each nation has its own peculiarities, of course, its characteristics. And in Brazil, we have an industry of a moderate size. The scientific production is still growing, and the agribusiness is a great actor to leverage the economy of the country, as we have seen over the last few years, right? Of course, as soon as man has started using fire, using tools, and discovered the wheel, we've been growing and growing continuously. This evolution includes several sciences that came up during this process. And we're going to talk a little bit about genetics, that as a science is relatively new. It's officially instituted in 1865. but it's only been rediscovered and considered as a science in the beginning of last century. So it's a very recent science, a field of science, but it has presented qualitative leaps over the last 100 years. So genetics is really one of the essential factors for production, for accessible production, and to increase efficiency. You can, together with different technologies. When we discovered in 1953, we were introduced to the molecule of life, the DNA, right? A new gate has been opened for new knowledge, and this has been evolved. And in the 70s, we had the start of the GMOs, genetically modified organisms, so we were able to bring them as a product. So just to bring this as an example, the GMOs sometimes are a little bit of a taboo in society, but we have a bacteria, Escherichia coli, that is modified, is able to produce with much more efficiency vaccines such as hepatitis B, insulin, growth hormone, which were produced by macerating the brains of the corpses, a much more complex process, and with genetic modification allowed us to do so. Also, transgenic products were introduced. The Savor Flavor was the first transgenic product that came up, which would last longer in the shelves, and the nectin that covers the fruit lasts longer. So, but unfortunately, the lifetime was smaller than the shelf time because people didn't accept it. Then we had soy beans as well, which is very close to us. All the discussion regarding transgenic soybeans associated to other companies' use of defensive products. But the fact is that now, today, Brazil leads, together with the United States, Canada, and Argentina, the use of transgenic soybeans, and makes us one of the great players of the world market. We followed the evolution, the first human genome project in the beginning of the years 2000 is a great leap for the use of genetics, because we can now learn that the genes work similarly in all species. So if we discover them for humans or other live beings, it's the same genes. So this allowed us to map the genome of many other live beings, like the bont vine genome from 2009, sugarcane, and many other genomes that have been mapped and that have been allowed us to move forward. And of course, all of this knowledge impacted the society from the cultural, from the social perspectives, involving a few taboos and a few creeds and beliefs that there's no way to deny that we have an exponential growth of humanity that we have not seen before. And to reach 150 million people, we needed year one. The estimation was that we had 150 million people around the world, and in 350 years this doubled. And only in the 1900s we reached the first billion of people, but then onwards it was a big leap. In 85 years we reached 5 billion people, and nowadays we have 7.5 billion, and the forecasts are for 9.5 billions by 2050, which changes the need for foods. So it's like we have a new China to be fed in just a few years. This is it's considered 70% additional food demand, and the meat segment alone is expected to increase from approximately 200 million tons to 470 million tons. And we're going to have to be able to prepare to produce this in a sustainable way. And the society has changed. There are now some social indicators that signals that there is a concern with food security and food safety, and also placed in the social media and the main big media channels. Our consumers are more and more demanding and sometimes things they don't even know about, but there's a demand, there's this all of this talk about the subject. And on the other side, the governments have realized that preventing diseases is much cheaper than curing diseases, so there's a process of public policies in this direction, and this includes nutrition and getting people out of these zones of famine all around the world. And this affects production efficiency. Regarding livestock production, we have different technologies that are being applied, and currently there are some simulations and discussions about sustainability. One of these issues are about methane, has already been discussed in other presentations, which has a very inappropriate metric that associates, especially to extensive livestock, the issue of irritation of ruminants. And maybe we need to develop some more technologies to measure this methane appropriately. Everything is transformed into carbon equivalents. The carbon lasts in the atmosphere much longer than methane, and this is not considered. And the capacity of our pastures for sequestering this carbon in a country that has 365 days of sun, which can continuously sequester this carbon in these pastures. This is not considered as well. And methane that is emitted by the rest of the industry and the urban cities don't have this pathways for compensation. So this scenario needs to be better understood and better discussed. We're not going to discuss the matter of water here. I just wanted to bring this subject because water is a big challenge for the near future. We know that agro business and livestock business is the greatest users of water in terms of production systems. So the rational use of water is something that needs to be considered and understood. Regarding the use of land, and thinking about livestock in this context, when we think about the biological value of the cultures, they are very, very different. So while soybean produces a much greater level of metabolizable protein per hectare, and corn, beef, the production of beef or livestock offers a smaller value. So, of course, we need to think about sustainable livestock production. But in the previous panel, someone mentioned that this green speech cannot go anywhere if your budget is red. So we see that livestock production has been changed to more marginal areas that have better biological value and economic value. So we need to increase the technology and mechanization of the livestock segment to remain profitable and sustainable over time. So according to the analysis and the experts, we are living from a world that was completely controllable, which was predictable, which was slow, which had impeccable references, absolute standards, and a vertical hierarchy. And we're going now into a world that is completely changeable, unpredictable, with it's fast and optimistic because of the speed of the information. It has complex references, multiple patterns, and decentralized horizontal power. And this requires a new way of thinking, not for livestock as well. So for each direction that we go now, moving forward, this sequence shows the historic sequence of the last big human crisis, the oil crisis, the Asia crisis, the American banks crisis, and shows the consumption of food over time. What happened is with the population kept growing and keep consuming more and more foods because there's no alternatives. We need to eat, right? The alternative is to die. So whatever the scenario, the population and food will be essential, of course. And this, excuse me, this is favorable because sustainability must be in harmony with the capacity to meet this worldwide demand. So we need to review some standards, some requirements in terms of sustainability, because producing foods will be necessary in any scenario. And the big question that we must ask is that in this scenario, is there still room for conventional breeders? And possibly no. Possibly these producers will not be able to keep their activities like this. And genetics is an important input, like I mentioned in the beginning of my presentation. And we believe that there are for large dimensions, for large classes of characteristics that need to be strongly optimized to have a more optimized and more sustainable production, which is reproductive efficiency, the speed of growth and termination, food efficiency, and adaptability to different environments. This is where the world is leading us, and that's what we need to work with. And the good news is that all of these characteristics, all of these dimensions have a genetic component that can be identified and improved. And it's interesting to note that genetics, differently from other inputs, is an intelligent strategy because it not deteriorates with time and use. Much for the contrary, there's permanent gains that are incorporated in any situation. So within the scenario, genetics is one very relevant and very interesting input and promising input to meet this demand, as long as we have appropriate information for the situation. Just to exemplify here, this is a work from 2013 showing the role of genetics. It was conducted in the United States. In these two columns, what they did is really quickly, they got the genetics of Dutch breeds and compared from 1944 compared with the improved genetics from 2007, and shows that those cows from 44, they ate less food, required less energy, but 69% of what they ingested just to maintain the animal. They only delivered a little bit more than 31% to produce this milk. With the improved genetics, this role is inverted. They eat, these cows, they eat more food, but most of what they eat is what they deliver as the milk, as the product. So the milk is no longer 15 millijoules of energy to 7.1 millijoules per kilogram of milk produced. So you can see how genetics in this work, 85% of this change was considered from genetics. Of course, there are some changes in sanity and the ratio used and so on. But the great change was genetics. And here the authors did a simulation. They've produced the same thing as in 1944 using the improved cows from 2007. What would be the environmental impacts? And you would require much less nutrients, much less area, much less water. You would produce much less waste. The GHG, in this case methane, would be reduced and have a big impact on the industry as a whole. So genetics can be a permanent component. And I would like to just contextualize very quickly in case of Brazil. The Zebu breeds are a very important component at the moment, that they can be adapted to our conditions in compared to other breeds. We need to remember that when Brazil was discovered, the largest mammals that existed were the tapirs. Bovines are not native from Brazil. They were introduced in the beginning of colonization. They were brought from the Iberian Peninsula, and they found a very hostile environment here. They generated, there are still some remaining animals of these specimens. They have their history value, they're here for 500 years, but they don't have any economic expression. Only in the 15th century that the zebu breeds were imported from India to Brazil, and they found a region that was extremely favorable for exponential multiplication. So the data show that about 6,000 zebus were imported from India. Let's say that it's double that or triple that. The fact is that this very reduced core multiplied, and now it represents 80% of our national herd, approximately 160 million animals with zebu genetics, which is the big basis for production here. This image from 1969, the big champion of a Nelore breed, compared to the animals from the beginning of colonization. Both are 7 years of age, bred in the same conditions, so you can see the different genetics can bring. Brazil has one of the pioneer programs in terms of zebu breeds, which is conducted by ABCZ. We're the first country to produce genetic assessment of zebu breeds all around the world. And now we're among the 3 largest players in terms of genomic assessment of these breeds. And it's important to remember that if we're talking about sustainability, that the benefits of genetics are cumulative, but the mistakes are cumulative as well. So it's important that genetics must be considered as input, because when the egg is fertilized by the spermatozoid, there's a new individual, and there's not much work we can do from then on. So just to wrap up here, we have here in Brazil the conditions to be a supplier of foods to the world, because we have area available. We can optimize the area that we use today. We have the workforce, which is a problem all around the world. We still have this workforce, although we need to invest in qualification. We have water, we have 365 days of solar radiation, we have research and development that are serious and ongoing. We have an organized land structure that is organized and reasonably stable. We have motivated producers, and we have an adapted and improved genetics. So the projections for 2029 is for increasing by 26% in terms of grains, 31% in milk, and 27% in meat. This is not only possible, but very feasible in our condition. This is my contribution. Thank you, João.
Perfect, Luiz. During the discussion stage of the panel, we can go deeper into the aspects of genomics, where Brazil is placed in comparison to other countries, and the potential of using these genetic techniques in our cattle herd. That would be quite interesting to understand. Now going to the second speaker, which is a kind of a complement to what we have spoken so far. Nutrition complementing the animal health and genetics, as mentioned in the previous presentation. So I'd like Luiz Adriano to present what Embrapa has developed in terms of technology. And we should remind ourselves that we are a pastoral country. We have used some technologies related to confining and some other techniques, but we should still use the pastures, because even though they have not only low costs, they can also help us in terms of carbon emissions. Luiz is a researcher of Embrapa Cerrados. He knows everything about livestock production and so forth. So I would like to hear from you what you have developed. Thank you, João. Good afternoon, everyone. Again, I'd like to thank you for the invitation. On behalf of Embrapa, I'd like to thank you and congratulate the organizers of this event. This is a forum that is a high point in the agribusiness sector, and our contribution by Embrapa, when we talk about efficiency of livestock production, we touch not only the genetics, which is something that we do not only in a partnership with ABCZ but other institutions, but there is the sustainable intensification too. We try to bring to you here the sustainable intensification that is materialized in two sets of technologies: the pasture recovery, which represents a very wide range of technologies, and integrated systems. Well, the integrated systems that we hope to bring, and we want to give a specific emphasis on some of them, including the integration between pastures and forests. Before we delve deeper into it, we should start by saying that our productivity in the livestock sector, both in dairy, cattle and beef cattle, is pretty much below of what we can see. The conditions that we have and the expertise that we have accumulated by research and producers is much greater. The potential that we have is much greater to the national average we get. In a dairy cattle herd, it reaches around 5 times below the potential when you look at the national average, and the beef cattle is not that far from it. The difference is that for beef cattle, we have had a faster evolution, and in the past years, we are also seeing pastures that are generating around 16 to 20 kilograms of meat per hectare per year. It's still, well, what we have in this scenario, as mentioned in the previous panel, we have a huge opportunity. The fact is that this is changing, and it has been changing quite quickly. The efficiency is on the rise, but we are not fully efficient in our livestock production. The point is that we have our entire system based on pastures, and we have a very large area. Around 18% of our territory is composed of pasture. The good news is that the pasture area has been reduced and the herd has been increased. This is an indication that the efficiency is improving, and in the Cerrado biome where we work, where we have 50 million hectares of pastures, and among this area, 26%, almost 27% of the territory of the Brazilian Cerrado is comprised of pastures. The reality is quite similar. We have an approximate herd of 53 animal units, 53 million animal units, and that results in an animal stocking rate of 1.0 animal unit per hectare. So the work that the science and research, the technical science and producers themselves, all these parties have contributed to reverse this scenario, because this animal stocking rate is the same we find in the remaining areas of the country. So we reach around 0.99 animal units in entire country in average. So we find almost same conditions in the Cerrado biome. So in terms of the pastures that are in good conditions in the Cerrado region, we have around 22.4 million hectares, according to data from the Federal University of Goiás and its respective geoprocessing lab. They estimate this area of pastures in good conditions. So You know that, of course, this picture is just a mere representation of these pastures, but still, when it comes to moderately degraded and severely degraded pastures, we have within these two categories 60% of our pastures in the Cerrado region. But we should characterize here what is the degradation after all. It is a process, an evolutive process. It doesn't start with a single factor, and it's not something that occurs instantaneously. It occurs with time, and in Brazil, some authors characterized the kickoff of degradation in pastures due to the lack of replenishing nutrients. This is one of the basic aspects, among other factors, numerous factors, and that is, we could say, the absence of pasture management or poor management and so forth. So there are several problems which with time will encourage other factors, and not only the loss of quality and productivity, loss of coil solver, the increase of weeds and pests, bugs, termites, and then the soil begins to lose organic matter. The soil becomes more compacted, and that culminates with the soil erosion. When you get this scenario presenting lighter degradation, which is almost imperceptible to producers, the cost to recover pastures at this stage, it is almost the cost of maintenance. So with the replenishment of nitrogen, phosphate, limestone, you can quickly reestablish the productive capability. And this is what the pasture degradation is about, is the loss of productive capacity associated to several factors. And when you move forward with the degradation, we also move forward with the need of resources to recover, to renew the pastures. So this is a logical manner for us to understand the problem we have in Brazil when we find very severe rates of degradation and the difficulty that producers have to reverse this scenario, because these situations would require great investments for the recovery of productivity capacities of these areas. This is slide I'd like to show to you now. It summarizes a huge set of technologies that not only Embrapa and universities work with, but several other institutions also work with that, as well as universities. So there's nothing new here, but there are two basic possibilities. Either you recover pastures that is interesting to recover them, or you renew, you renovate, you perform a renovation, you exchange the plant that grows on these pastures. That can be done directly with fertilization adjustments. There's a series of alternatives so that you can do it in a direct or indirect way, which involves the use of agriculture as an intermediate in this process, both for recovery or renovation. When you use it for lighter cases, when we are talking about the green cases, you are not destroying the pastures. You should not destroy the vegetation, or you can destroy it partially, or you can destroy it completely, and you encourage again the growth of these plants. Or you can also use different crops as well. That is done both for recovery or renovation, but once these various technological possibilities are adopted, you can get either a recovered pasture or a new pasture. Many producers use, for instance, the recovery or renovation without agriculture, and we are going to show you some examples, which is the most common form of using, but the direct renovation is one of the most common manners of doing that. however, is the most difficult way for producers to re-establish the invested capital. This is one of the problems we find here. When you have to exchange the pastures, you get a new pasture, you do it directly, and it takes time to have this investment paid back. So when you have a pasture that is mildly degraded, you can apply limestone, you can perform a direct recovery, and there is the recovery that is established at not so high cost with reasonable returns in terms of milk or beef. The more you get problems of accelerated degradation, the costs get higher. So in red we have the costs and in blue the returns. So if you have a quite evolved problem, you will possibly have to use agriculture as an intermediate stage with higher costs but with higher possibilities of return. So there are several alternatives here. Look at this example by our colleagues at Embrapa. If you have pastures being recovered by 90 kilograms of nitrogen, you have an interesting return in terms of productivity when it comes to live weight gain and yield, and also an interesting production in terms of the weight of beef per hectare. But when you have a recovery of the pastures using soybean, the yield and the results are much more interesting, especially when you look at the weight of beef produced per hectare. So it goes to show the potential that we have compared to the national average to improve our livestock activities. Yes, there are investments for one to make, but soybean has a recipe that is not included here. The soybean pays for this investment by itself. These are alternatives that producers have. People are aware of it for many years, and what we need here is a sort of encouragement to reverse this scenario. This is a very well-known picture that was taken by a colleague, a good friend that we used to have, our good friend Armindo Kisho, who unfortunately was deceased last year, but you can see here the differences where we can have either low or high yields. Yeah, absolutely we should make investments, but there will be returns on these investments. So you should go after the science, you should go after technology. As businessmen, as producers, you should understand that your business should be feasible in each and every aspect. It should be sustainable in each and every aspect. And furthermore, when the pastures are recovered after the agriculture, you have a very high increase in the photosynthesis ability, and that includes the capacity of sequestering carbon. So this shows the potential of these integrated systems have, either as recoverers or renovators, either at a direct or direct manner of these pastures. I brought an interesting work we did here for technology validation at a farm near Minas Gerais, where we had a degraded pasture at these conditions. At a farm called Agro Reservas, we planted on 100 hectares, half of it with corn silage and half of it with standard corn. So a basic Santa Fe system that a lot of people have been using in Brazil, and the idea was to test. Producers wanted to understand if this could work out well. So we did an off-season crop here that was planted in January, if I'm not wrong. So it was harvested in May, and by the time we managed to get 90 bags of corn per hectare, and by July we could manage to get a fully recovered pasture with a weight gain of 450 grams per head per day. Of course, the genetics was a contributor factor here, but everything else that we did also contributed very much to these good results. So not only the harvesting of the corn silage paid for the investment that was made, we could also reuse the fertilizers that were left over from the planting activities. There's a good cost amortization. This pasture recovery or renovation will be paid by the agricultural activity. And you will also get a green pasture in winter or dry season. And this is very important in Cerrado region because we have 6 months of rain and 6 months of drought. So we can get a weight gain at the most critical period of the year. So that's a very good thing. And with that, you get an improved production, liquidity, feasibility with these integrated systems. Another example we would like to show to you is an example at the Campina farm, where we did a work for 7 or 8 years, making the validation of these integrated systems. We began to adopt these integrated systems around 2012, 2013, and he has a system where he plants soybean and corn silage for 2 years, and then pasture for 2 years. So we can see here the reduction of the pasture areas and the increase in the stocking rate in the farm. So it shows the efficiency gain that they had and also amazing genetic gains. Just to detail the direct planting that we had, the soil was quite challenging, but still we get very interesting returns for soybean and corn. And the producer says that his genetic was completely modified, and when we start seeing gains, these things are pretty much appreciated. And he saw gains that he had never seen in his farm in a period of 40 years, such as the increase of weaning weight, the insemination between 10 to 14 months, super early heifers, and they gain 1 year because he's also a seller of genetics. So this shows a huge gain. Sometimes it exceeds more than 1 kilogram, but in average the gain was around 469 grams per head per day. So the integrated crop livestock system has been researched by Embrapa since the 80s. We have technology, we have the knowledge. There is a series of information on this system. The most recent challenge involves many cases, but still there is the integration between crop, livestock and forestry. Here you can see the first years while the trees are growing, and then after a few years you bring the animals in. This system increases greatly the diversification and intensification of the land use. You can get grains, beef for milk and wood, and with that you decrease the deforestation pressures. You had a sort of a land saver effect. The animal well-being is highly increased. The shadow that is provided by these trees increase a lot the well-being of animals, and you of course get better productivity rates and weight gains as well. Just to give you one example, you can see here 60 hectares being handled with this integrated system. You can see here the animal stocking rate and the live weight gains that are much superior to other systems. When we compare to the average that we find in Brazil, you can see how much do we have to gain, how much we can grow in productive potential using these techniques. When it comes to milk, we have this work being done at Embrapa Cerrados, showing Zebu cattle compared with Girolamo in this integrated system, and we can see an increase of 24% increase. There was a decrease in the body temperature of 2 degrees.
Nos sistemas de LPF, tempo de ruminação maior na área de LPF.
we also saw a rumination time of 22% and an 18% higher productivity in early stage of lactation, 17% higher productivity during the dry season, during the ICLF, and that's not to mention reproductive indicators and some others that are benefits that are provided by the system. Furthermore, we also have many good results that indicate that these ICLF systems promote a positive GHG emission balance, because even though the emissions are constant, there are possibilities of having a direct reduction of emissions by a balanced diet and other possibilities. But yeah, animals keep on emitting methane by enteric fermentation, but there is the sequestration of CO2, and there is also the important aspect of animal welfare. So there are huge gains to be achieved here. There are metrics being analyzed by we at Embrapa Cerrados, and we can see a very positive balance in these ICLF systems, and we see the carbon stock entries making a huge difference, and that's a very good thing. And getting to the final slide, with that, Embrapa created a brand or a sort of a concept trademark that is an auditable protocol that aims at the certification of meat with ICLF or ILFL systems. This system has been supported by the MyFree product company, and with that the meat is then able to receive this seal, becoming a meat with an added value and a meat that can then demonstrate its added value and all the careful process and the accountability that the producers wish to provide in these integrated systems. This is what I wanted to present to you. I apologize if I exceeded my time.
Thank you, Luiz. We're going to have a little bit more time for our discussion, to have a little bit more information. We know that currently Brazil has exceeded 15 million, more than 15 million hectares with the adoption of ELP and LPF systems. So this is a reality already, and it's a no point of no return, right? So I'd like to call Cris Morais, civil engineer, rural producer, president of the Secretary of Livestock Chamber of the and she's going to talk about her practical experience on the daily routine of the farm. Let's see how is the daily routine of the farms, right, Chris? If these technologies are adopted, how these processes are dealt with, and we're seeing that, is this feasible, is it not? Can we be paid for it? Please tell a little bit of your experience and on your farm, using all of these new solutions and focusing on sustainable production. First of all, thanks you all to be here with all of you, João, Luiz, and also to the organizers of this huge event, GAF 2022. I'm going to introduce myself. My name is Cris Morais. I'm a civil engineer. I'm a rural producer. I'm here as the president of the Livestock Chamber at the Secretariat of Agriculture of the State of São Paulo. I'm also coordinator of Agro at SENEC. Just to understand, SENEC is the Women Entrepreneur Culture Council, which is part of the São Paulo Trade Chamber and FACESP and CACB, with more than 2,300 commercial associations, trade associations in Brazil. In this discussion today, I'm going to share with you inside the farms how we can have more efficiency, increase the animal units per hectare, having more technology, and with precision agriculture, without forgetting the basic principle, animal well-being and sustainability. So I call It's the mega arroba cropping in beef cattle. But we need to understand why do we have this mega arroba cropping. Because we have to understand what we're going to sell. What we're going to sell to the slaughterhouses. They have we have the small animals, and we sell directly to the slaughterhouse. We sell kilograms of carcass with sustainability, because my land is certified by CAR. I already registered with PRA here in the state of São Paulo, and I have environmental surplus from my land. So this means that within the biome of my land, I'm also doing my part, because more and more people are aging, and there's more people in our planet, and people want to eat better and better food, right? So I sell the kilo of carcass with sustainability, because the good practices of every day of the whole communication of the protected chain link inside and outside the farm, this is the importance of great communication of sustainability, because when we are selling this kilogram of carcass with sustainability, this means food security. This means that the families have food on their table, on their plates, and I'm able to know the results when the cattle is sold to the slaughterhouses. So this is my good practices. My good practices are every day, all day. And in my farms, they don't drink. The cows don't drink water from the lakes or anything. The whole land is fenced. The water resources are preserved, and they only drink from the wells. So we need to dimension all the infrastructure to bring this water to all of these pastures. So we need to dimension the infrastructure, the flow, without forgetting the manometric height of your pump, if you have a pump, if you have a water reservoir. So the next slide shows the pillars that I discussed, some of them already. So this conversion and increased production per hectare into sustainability and animal well-being with management, entrepreneurship, genetics, technology, precision agriculture. Without any of that, we wouldn't be able to do it. So it's really important to have this whole communication of the productive chain. Identify each link of this chain, item by item, where you can have more efficiency. In our land, we divide it in two scenarios. The droughts and the floods, right? So it's very important to understand what you're going to do. Because the boys here, they had great presentations showing what science teaches that it's possible to do. And we, inside our farms, we have the obligation to be together with them to increase the production per hectare. And why we call it mega arroba crops? Because we need to take care not only of the pastures inside of my farm, but also the corn, because we have corn silage during the drought season, and this allows us to supply safely to our cattle as food, and in consequence, this is the food that we're going to consume later on. I'm going to show to the next slides because it's more interesting. We have some pictures. This slide, I could use this slide alone to do all my presentation, but I'm going to show you some pictures. We need to move the cycle, right? The cows need to be bred, need to be born, need better genetics to have better performance. Because currently, why we have this mega arroba crops is a small rural land which would increase the production. Today we have 6 animals per hectare. It's aggressive, but that's why we have good financial management and planning. And the cycle needs to move on, because the cattle goes to the slaughterhouse. We need new cattle to be going into the farms, but each step is identified. So each step is treated individually, and we have 3 types of with grass in there. But we did the land leveling in all pastures to have increased performance in each of them. And how we're able to do this? With science, research and development, and technology. And in execution is the day by day, which you're going to see in the next slides. And the result is the financial freedom that we have to be able to pay for your costs, to offset your replacement, and allow to travel around the country. You need to have the control of your balance of your cash flow and your accountability. You can see this slide that we have the car certificate with the environmental surplus, considering that biome, the Brazilian Cerrado, and we are doing our part on this daily routine, which are these actions that everyone can do to not only increase agro production, but increase production indoors. Do you recycle in your homes? You need to start this at home. Glass. I lived in Switzerland for 22 years ago, and there at home, at the farm, we do recycling of glass, paper, plastics, organics. These daily actions, not only inside the farm, that allow this identification. And the car with environmental surplus, that's why I sell the kilogram with sustainability. And since no animal enters the preservation areas and we preserve the water resources, we're doing our part. And this is what I like to show to everyone, to make it clear for everyone. There are rural producers and livestock producers that are reference for the world. I'm going to show you a few of the technology actions, I think. Okay, let's go back one slide, please. As you can see, it's been years and years of doing some changes to be able to adapt ourselves to improve efficiency, improve productivity. We can no longer measure the producer by the size of the land, but for the capacity of conversion, their productivity, with sustainability, with good practices, with good management and governance. Your actions will define if you are a good rural producer or if you're a good manager. And there's no miracle, right? Debit, credit, and balance, right? Sometimes it's not easy to understand this, but the most important of all is for the rural producers, the livestock producers, this sustainability and animal well-being are very important, because food security starts on the feed that we give to our animals, and as a consequence to have better food later on for us to eat. You can see here there's a well. They only drink water from the wells. The cattle does not drink water. We wash all the infrastructure every week, and depending on the weight and the time, we need to wash all the infrastructure every day. And the troughs. This will result in increased weight, increased sustainability, and of course, don't forget the manometric height of your water reservoir. You have to wash the troughs. You have to have this water pressure. You can see here the pastures as well. Here to understand in terms of animal well-being, we have the big pumps, and now we have the concrete troughs that are pre-molded concrete with the integration of in each item of animal well-being. We assess. I use a horse, and I apply the same standards for the cattle as well. There's no. We use flags. We have some place where we confine the cattle and everybody is able to work safely. It don't matter if it's a small animal or a big animal, if they need to go, or a full-sized animal that is going to the water house. It's almost 600 kilos to keep them safe, not for the animals, but for the breeders as well, and everybody who works in the farm to be able to work safely, to do some curing, to improvements, apply the vaccines that are required. But all the time, food security and food safety is double. It's double. It's double. It's for the animals and for the food that we're going to consume as well. Here you can see the division regarding the types of grass. Agriculture 5.0 in each pasture. In each pasture we use GeoFert. GeoFert is the latest technology in precision agriculture for soil analysis. We use it in all pastures. There's no contamination with the samples. Each grid, the drill is 0.20 centimeters, then 20 to 40 centimeters. The samples are not contaminated. They're taken to the lab. So as I mentioned, we have 3 types of grass. I can control each type of them. Of course, don't forget the handling of the pastures is really important. Do not allow it compact near the troughs. Both of the troughs need to be there. The less this animal has to walk, the less energy they spend. So if they have to walk a lot, they're spending this energy to walk and not to turn into production of protein. We use all this data, put it into the software computers, and with the technicians and agronomists and veterinarians, we do this supplementation to have better production and have a more economic production in the rain season and the drought season. We have the latest technology with the computer that allows us to, for each batch, we know exactly the time and date. We have all of this information. So when we're going to correct the pastures here, we apply these products with a variable rate, even for the limestone and fertilizers as well. Without fertilizers, we can't increase our efficiency and our production per hectare. It doesn't matter if pasture or supplementation with corn, because it's either goes to the silo or goes to the ratio, and this ratio is going to the industry, then goes to the farm, and then together with the silo we are able to have better performance and improve the efficiency of this kilo of carcass with sustainability. As you can see in the second picture, when we are going to apply the fertilizers, it's an outsourced service, so we have a technician with a truck, and we do the application. We have the computer there, so they apply the product exactly. The first year it was a lot of resistance to do it, but what I saved with limestone and what I saved with approximately 30% of limestone in the first year because of the precision, accuracy, and exact application of the fertilizers. Now supplementation, when we go to the drought season, the cycle continues. We need to sell our kilo of beef. So we have the silos. Since it's a technology that has already been implemented, we have horizontal silos and long, as you can see, and the efficiency of the machine, of this piece of machinery there, they're able to load the silos at an almost 1 meter of height, and with this machinery they're able to load and mix and apply the product with precision agriculture. This is the communication between all the links in the productive chain, and we can do our own assessment. You can assess what we have in our farm so that we're able to do the correct supplementation. In this farm, we selected to do corn silage, but you need to look for your biome and see how you need to do it on your land. And this is the final result that we have. you can see that we have animal well-being. I'm lying down there of the batch 2 years before going for the slaughterhouse.
500 quilos.
This is an animal almost 500 kilo that I can open the door, considering the well-being and work with the animal within this containment part. And we also use the good practices inside the corral. There are circular corrals nowadays. There's no pictures, but we did it in our farm. Some rotating door that you push the door, and this reduces the time of the animal being there at this moment from entering the corral and then going through all the parts of the corral. This improves efficiency on our daily routine, improves the productivity, and to have this final result, an average slaughter in our batches, new animals, 3+ fat layer, and yield of approximately 62%. But this is the big communication between precision agriculture with science, research development, genetics. Without that, we wouldn't be able to do it. My project there is based on the animal 777, which really helped us to revolutionize livestock. 7 months for breeding, 7 months for fattening. This is what I wanted to share with you, because yes, it is possible to do it with a lot of entrepreneurship, with a lot of planning, with a lot of correct management, and a lot of sustainability, and many actions between all the links in the productive chains. Thank you. Thank you very much. Thank you, Chris. A lot of control as well, right? Because this is a system with high efficiency. I think your presentation sums up what we were discussing here in practice. It's not, unfortunately, we have not a long time we could see your spreadsheets in detail. Would be really cool because we could see your results. Because you have positive results, otherwise we would not be keeping it in operation. With this quick turn, probably this will give you good speed and good gains in terms of productivity. We have just a few more minutes. I'll ask each one of you a question. I'd like to Luiz ask us, Dr. Luiz asks us, what is the potential for growth that genetics still have in Brazil? I mean, it's polemic subject. There's a deficit in whole Brazil of animals per year. We need to grow a lot. We're still talking about genomic, and we have a deficit on small and medium properties and lands. We need a program for genetics to achieve this goal of permeate this genetics at the base of the pyramid, because the small producers, they produce the small animals that are going to support the breeding of whole countries. So what are your figures, and what is the idea we have in terms of potential for growth for genetics in Brazil?
Well, João, I could say that we are basically just starting the process. We are just scratching the surface when it comes to what the genetics could offer. Sometimes we could be idealizing a process, but then we would have to have a program with at least 3 million cows so that they could produce a number of animals, and then we could have the half of this number of male animals. Let's say that we could have around 1 million male animals being born, and in theory would have half of this population that could be improvers. So this ought to serve this commercial herd of animals that would result in a number of 30 to 40,000 oxes per year, but we would need to have, yes, a very large program. We do have this potential to be exploited. I think this is the good news here. Yeah, I believe that there's a lot of room for new genetic producers here. Yeah, there is this possibility of taking the genetics to small-sized and medium-sized producers. We have created commercial mechanisms that the improving genetic could have seemed in the past quite inaccessible to producers, but it is accessible. I think that these returns can be available quite soon, and it is perfectly possible to work on that. And Progenetica is one of the programs that is trying to improve this process. I was thinking when Luiz Adriano was showing that improved pastures, how using an inadequate genetic there would be such an investment badly used there. So this is something to pay attention. Yes, I think that there's a lot of room for us to grow and how we can adopt genetics of how we can adopt genetic as a way of verticalize our activities and finally achieve a more sustainable and long-term livestock activity. Luiz, you presented so many interesting and important solutions in the sense of increasing productivity. Today in the morning, Marcos was talking about the ELPF integrated systems as being one of the revolutionary technologies that Brazil is presenting. What is the major difficulty of using this concept and bringing this concept to small and medium-sized properties? We are a continental-sized country, but I believe that we have seen so many solutions, and we are talking about the systems for so long. He was one of the protagonists at COP26. I was personally there presenting integration systems as one of the solutions for the Brazilian livestock activity. But what is the challenge here so that we can expand that and make it more accessible? What are the challenges? Yes, you mentioned some of the possibilities. Yes, we should work on the transfer of technology because we have our own technologies. We should be proud of that. There is nothing that was created abroad. This is our reality developed by our research and with the contribution from our producers. Many of the solutions come from things that producers identify first, but it is natural that Brazil is demanding technical assistance. We do have a gap when it comes to technical assistance in most of the states, and we can say that the private technical assistance cannot handle all the demand we see here. Small and medium-sized producers, they should look as possible companies that can help and bring at least some minimal guidance. And maybe these could be cooperatives, associations, but what we are trying to do is try to keep the speech, the discussion going. I've been working with this for more than 20 years, and there are colleagues at Embrapa who have been working with these integration systems for more than 40 years. But what do we know so far? We know that these systems increase the level of diversification, the economic feasibility as well, but they're more complex in their management. So producers, either livestock producers or farmers, when they have large properties, they have conditions of absorbing these investments. Farmers, as though it might seem strange, they have more ease to join these integrated systems, but that has been changing because we are seeing younger generations or producers who are looking for new alternatives in face of crisis, and the information is there. The information is available. When it comes to Embrapa, that is a public company, most of the publications are available in PDF file format on the internet. People who want to find information can find it. So I would say 2 words here. Yes, there are credit lines. There is ABC Mais, with a renewed program that brings advantages and some benefits, but this cannot be solved by the use of credit only. We should take knowledge and the change of attitude to these properties. And this is a challenge, and it's understandable. We understand that producers might find it difficult because there is a huge gap of technical assistance, and our knowledge and technology transfer process is slow. We at Embrapa, we generate technologies, and we try to transfer part of it. But in the 70s, this was performed by technical assistance companies, and they are slightly behind. I believe that the challenge is for producers to look for information and qualification. Yes, considering that the information sources have expanded today, you have your smartphone, you have many possible ways that would not be available some time ago. And there is something that drew my attention in your presentation, is that you mentioned the amount of kilograms of carcass per hectare being sustainable. You used in a very assertive way this terminology to your product. You're selling this product with this competitive edge, this yield at around 60%, and you have this award that is paid, and it is interesting at your results. So yeah, tell us about. Yes, we try to do what the food security requires us to do. So we should, yes, study this entrepreneurship, technology, the use of fertilizers. Yes, we are able to produce our own fertilizers here domestically, and I am adding value to products, but I can only do that to the products that I sell because I'm doing my good practice, because I am adding technology to the entire productive chain so that I can sell it to the cold storage companies at good prices. And they can only do that because we have a very long chain in the livestock industry, but I have a very good conversation with many of these links involved in the chain. We have a good conversation with the agrochemical industry, with the food security aspects, and food security that we are talking about here, not only the animal welfare and not only for the herds, but for us who will eat that food. This is a matter of public health. Thank you very much. I'd like to thank the members of the audience who have watched this panel. I'd like to thank Luiz, Adriano, Luiz Josahkian. It is a shame that we have to interrupt, but I know that we could have kept on talking for hours and hours on end. This is a very good and interesting subject that can be very fruitful to each and every one of us. I want to thank you for the invitation and for this opportunity.